Hello, my name's Matt Crook. I work on LET-23 signaling and lipid synthesis. That's what this poster is about. Thank you for clicking on my link, and if you'd like to know more, just follow along, I guess. First time I've done this, so excuse any shakiness. Okay, so this is all about the effect of overactive EGF signaling, particularly through the LET-23 reporter, on lipid synthesis. And what we've found so far, if you look at the other poster in the Dropbox folder, is that you overactivate LET-23, you get less fat. We also found that if you do that with LET-60 gain of function, you get the same result. So essentially what we want to do is try and figure out the mechanism, how those two things linked. And so first thing we have done is to use a SBP1 GFP translational fusion. You can see it here. Let's see if this works. There you go. So this is what the fusion looks like in, I think those are L4s or young adults, right? So you can see the intestines lit up. You can see the GFP in the nucleus, which is the bright dot, and the cytoplasm, which is the fuzzy bit around that. So our idea was to use that as a marker and see what effect our manipulations in terms of mutations or RNA has on its cellular localization. If the GFP is more in the cytoplasm, it's inactive, right? It's sequestered in the rough endoplasmic reticulum. If it's in the nucleus, then obviously it's active and can activate lipid synthesis genes. Right, so that's one thing, and we'll get to that again in a little bit. Second thing was to look at essentially the output transcriptionally of that manipulation. So if we overactivate LET-23, what effect does that have on the transcriptome? What genes are expressed relative to wild type or normal animals, right? And we also included an SBP1, so that's the lipid synthesis transcription factor in worms, an SBP1 loss of function mutant. Okay, and again, look back at our previous poster from the previous worm meeting for more info on that. Okay, so getting to the SBP1 GFP readout. Oh, wrong direction. Here we go. So first we looked at gain of function mutations, right? So we've got LET-23, zoom in over here, or just move the camera rather. We've got LET-23 gain of function, which is the overactive receptor. We've also got mutants, gain of function mutants in the two known pathways downstream of that, which is LET-60 RAS and ITL1, which controls calcium release from the ER. And what we found, even though those error bars look enormous, is that if you overactivate LET-23 or LET-60, you get more GFP in the cytoplasm and less in the nucleus. So there's less active SBP1 GFP there, right? And if you look at ITL1, the other pathway, you don't see any difference. So that tells us that not only does the lipid synthesis or effect on lipid synthesis go through LET-60 RAS, but also at the bottom of that LET-60 RAS pathway, there's an effect on SBP1. We're not quite sure how that's linked together yet, but that's something that we're thinking about. Okay. Sorry, that was my dog. So the opposite of that, right? So if you're thinking about overactivating these particular members of these pathways, there's my wife and daughter.
Who are we talking to?
It's a presentation for my poster. If we do the opposite, we can knock down members of those pathways, and if the previous results are valid, we should see the opposite. And so down here it goes down, it's more cytoplasmic, less active. If you reduce gene function, it goes up, and so it's more active, right? So we've got a real good confirmation that whatever LET-23 is doing to lipid synthesis, it's doing it via LET-60 and MPK1 to affect SBP1 activity, essentially. Okay, we also did the same experiment but in a LET-60 gain of function background, and we were able to increase it from no RNAi, essentially, right, if we knock down LET-60 or MPK1. Okay, moving swiftly on. Well, wrong direction again. So the next thing that we did was a transcriptomic experiment, which was essentially to compare differentially expressed genes in LET-23 gain of function mutants with those in SBP1 loss of function mutants, right? So theory goes, if LET-23 is acting on lipid synthesis via SBP1, then at least at some level they should look pretty much the same in terms of their transcriptional profiles, right? And that's what we see. We see about a pretty big overlap in downregulated genes and a smaller but still fairly chunky overlap in upregulated genes. Interesting as well, there are much fewer genes differentially regulated in LET-23 gain of function versus SBP1 loss of function, right? A little bit of data bashing. We figured out what all those things did as best as we could by annotations on Wormbase. And we found that in terms of expression, most of the differentially expressed genes were in the intestine and nervous system, right? And that makes sense, particularly in terms of the intestine, because that's where lipid synthesis is pretty much focused, right? And the other includes a whole bunch of stuff, right? Just get in contact if you're interested in anything in particular. In terms of function, one of the biggest single categories, at least, was protein production. But something that was really interesting was the effect of the presence of, differentiate regulated genes in terms of bacterial defense and carbohydrate binding, right? So that was the most strongest go term in terms of go term enrichment was for bacterial defense and infection. So that's something totally new. And as far as I'm aware, hasn't been associated with EGF signaling before. Okay, and just to give a little bit more detail, go down a little bit here, we've got it in text here. In terms of the up and down regulated genes, actually what they were, there's a bunch of, poorly annotated genes, right? Ones which haven't actually been worked on directly. And the two top upregulated ones were a phosphatase and a fibronectin-like protein. Real highly upregulated. Also divergent on the genome, so they share about a 1 kilobase possible regulatory region between them, right? So they're kind of pointing in different directions on the genome. And that's also the case to a slightly lesser extent for two of the three most downregulated genes, PUD3 and PUD4. PUD stands for protein upregulated in DAF2, long-lived mutants. So that's kind of interesting as well. So anyway, a lot more work needs doing on that. If you are interested in any more of this, please feel free to contact me. My email address is Matthew with 2 T's, .crook, CROOK, at TAM, wait, leave that alone, that's mine. USA.edu. My dog was trying to eat my biscuit. Anyway, thank you for listening, and I hopefully see you around.